My name is Tim Hahn. I'm Chief Architect for IoT Security within IBM. So if you hadn't heard the news, IBM has a fairly large investment in the Internet of Things, which means quite a lot of us are working in this space. And my role is to make sure that the guys and gals working on this pay attention to security at all stages, which, as we'll get into, I think is very much about the devices, and is very much about more than just the devices, which I hope you all agree with. I would also, even before I start, very much echo what the guys before me had talked about, that what we're seeing with Internet of Things devices and vulnerabilities should not be a surprise to anyone. Whenever you connect something to a network that hasn't been connected in the past, and it wasn't necessarily thought through from the beginning to have that type of connectivity, you're going to find some vulnerabilities. And just like if you take a default system and try to run it and connect it to a network without changing default passwords, without setting up some security infrastructure, on any type of computer, whether it's your phone, your tablet, a PC, a server system, or anywhere else, it's going to have vulnerabilities. So it's not like this is anything new, and it's just another stage in the evolution. There are some things that are new that I'm going to try to get into here, but these are not new things, and I think some of the exploits that we saw earlier in the day point out just how not new it is. We all sort of roll our eyes and say, how could you do that? But then you think back to when you were a developer and you were pressed to put something out, and you said, oh, I got to make Friday's deadline. All right, I don't like it, but I'm going to do it anyway. And you all probably go, yeah, you probably stare at the mirror tonight and go, yeah, I probably would have done that. Not be happy about it, but you probably would have. And so that's where we're at. All right, let's see. How about this? So why is IoT different? I just got done saying why I think IoT is actually rather the same, but IoT is different. There's a lot of devices, a lot of device types, a plethora of systems. We heard earlier today a question about, well, will there be consolidation? Will it all run down one vendor? I don't think so. Yeah, I think there will be consolidation in the market, but I don't think we'll get to one vendor, simply because of this diversity of the devices themselves. Either diversity in cost, or diversity in deployment environment, or diversity in usage, or the types of information that you're moving around. There's just no one platform that's going to hit the right cost performance model that'll overtake everything. So I think you'll see a wider range of device types continue for quite some time. Scale, we'll argue about the number of zeros, or the powers of 10 that will happen over the next several years. But it's clearly more than the number of devices in people's pockets and the number of the devices that are in server farms and cloud-hosted systems and so forth. I saw a number from a company just the other day that says they ship 300 million motors a month. And I scratched my head and said, how can they ship 300 million motors a month? But then I started doing the math in my head, and I said, yeah, I could probably get to 300 million if you think about all the motors in the world. And if you try to think, if you instrument all of the motors in the world, that's a lot of motors. So I at first thought that can't be right. That's a crazy number. But now I'm starting to realize, well, there's a lot of motors in this world. If you extend your range of motors from everything from an engine motor to a locomotive motor to the tiny itty-bitty motors that run in a variety of different devices in the world, you can get there. And then there's this complexity. There's a complexity of protocols, there's a complexity of operating system types, there's a complexity of all sorts of things in this space. That sort of brings in why IoT is somewhat different than what we've seen in the past. There's been consolidation in the other areas, in systems, in cloud environments, at least in cloud and virtualization types. There's been consolidation in sort of PC architecture, consolidation even in the areas of mobile devices. There's sort of a handful of these things that really have risen to the surface, and everybody else has sort of converged on those. In the IoT space, we're still in this divergent area. It will come together, but it won't come together to one or two. I think we'll have quite a few more than that. The security risks in the Internet of Things are far greater. I don't want to paint a horrible picture here, but far greater than just in the devices. The devices are nice, juicy things to go after because it's fun to take them apart. It's fun to use the wires to connect things. They look cool, and you can make it do funny things and cause shock and awe in the audience, and they cause great media events. But let's not forget that the rest of the environment needs to be secure as well. Even if once I get the data off the device, or I can exert a command to the device, what about all the systems around that are supporting that environment? Furthermore, the devices do move around, so there's a vulnerability by the fact that they're not necessarily in one condition. That, by the way, can also be a benefit to devices. So I've been telling people lately that the security of devices might actually come from there being an aspect of it, might actually come from their being nimble in the way they connect. So a device may protect itself in a couple of ways. It may defend something, it may defend against attack, it may hide, or it may run away. And running away might mean run to another spot from where an attack is present. So keep those things in mind. As being a device, the mobility might actually help devices out in the level of security and the way they respond to attacks. There are all the security and privacy issues of the data generated by those devices. We heard the woman talk earlier today about medical information and how privacy aspects need to be applied in there. There will be privacy concerns not just with medical information, but as we understood, location information is important. Consumption information might come into play as well. And one of the things I've noticed lately is there's a secondary effect of information by itself not being considered personally identifiable, but because of the repeated patterns by which that information now exhibits, something becomes effectively personally identifiable because the inference you can make from it is good enough to say it was me. My example of that is my individual fitness track, or my individual GPS tracks for my fitness device aren't necessarily personally identifiable. But if you take enough of them together, you'll realize what my address is. And so you can infer information about who I am or what I am from information that didn't have any personally identifiable marks in it, which is something we didn't have in the past, but because of all this additional information being gathered, we now have to deal with. And I think that the HIPAA regulations and other regulations on personally identifiable information don't quite cover this aspect yet. So we as a community have to get out in front of that and realize what we need to do there. The compromises on devices, well, this goes both ways. We could attack the devices, or the devices could attack IT or the systems. So once you own a device, if I can own one device, I can own a plethora of them. Now if I have a wide range of these devices, I can create large DDoS attacks without trying very much, because I don't have to own a lot of different systems on a lot of different networks. I'll have a much wider set of devices to use in such attacks. And it goes the other way as well. If the IT systems or the applications or the rest of the computing environment used for these IoT applications gets attacked, we can now exert influence on the devices, which is not a good deal either. All right. In this diagram, which I use in the security point of view document from IBM, what we try to articulate here is that the devices and gateways sort of show up in the lower left-hand corner of this picture. And there's a lot of the rest of the world around an IoT application and solution that you have to remain aware of and remain vigilant to. There's what we do to collect that information, how that information flows from one point to another, whether that's between devices, through gateways, up to some systems running in the cloud, or otherwise. We have to worry about that data protection. What we do with the data once we have a hold of it, where that information is stored. This is not the only model. It's probably the most common model I see being used today around building IoT applications. There are several IoT application models starting to emerge, such as large storage vendors creating IoT storage units. And so the thing being advocated there is, why move the data around when I can just collect the data and store it where the data is being collected? That cuts both ways, because as we've seen, if you can attack the device, then you actually get access to the information. So you have to weigh the pros and cons of what risks and threats you want to worry about as to what application architecture you use. But then there are the applications and what I termed as application interfaces, for lack of a better term, on the right-hand side of this diagram. As we know, each of those will have threats, and each of those threats will have some set of mitigations. Some you'll like, some you won't like, some you'll decide not to address and just list as a potential vulnerability. Some that you'll be compelled to address in one way or another, either through designing something in and building it in, or through required operating procedures. And I think that I don't know if it's a demarcation, but this categorization of design and manufacturing and operations, this is applied in IT infrastructure for many years, and it applies in this space as well. There's designing and manufacturing the devices themselves to be as secure as possible, and then there's also the operations of those devices to add additional security or to mitigate situations that are not taken care of by the design and manufacture of the devices. So when I look at this diagram, when I look at it, I actually see it as the previous diagram spun on its head. But I leave it in here because it shows, again, the vast number of interfaces to be concerned with Internet of Things applications. We have the devices and sensors and controllers and sensor hubs and into the gateway space, as we've talked about most of the day here. Yep, there's a lot of potential attacks and a lot of risks in that space. And by the way, almost like a fractal environment, this is self-similar if you look inside the devices. A vehicle is a very good example of that, being a complex IT infrastructure within a vehicle. There are other examples of this as well. Almost every moving vehicle you can think of has a similar type of thing. Aircraft? Yes. Locomotives? Yes. Buildings? Yes. So this thing is somewhat self-similar in its construction, even though I don't show it on this page. But each of these spaces, or each of these elements, is a place for attack, a potential risk, and a potential attack location. So when we IBM think about IoT security, we first think about what we sort of look at from an IoT perspective. We sort of think of the IoT environment as a combination of devices and networks, platforms which connect those devices to either applications or to other devices, applications and solutions built on top of those platforms or in those platforms, and then industry-specific transformations which collect applications together and provide overarching solutions in various industry spaces. So the security characteristics that we are creating are really set up to address all four of those areas in one capacity or another. We're doing work with on-device security technology to analyze behavior within a device to point out potential vulnerabilities or potential attacks that might be occurring in devices. We are securing our IBM IoT platform for authentication, authorization, auditing, and data protection, as well as providing additional risk management services on top of that. One of the things that I want to sort of stress here is that not every IoT application necessarily demands the same set of security characteristics or security technology applied. The easiest example, the safest example I'll describe, safest in terms of being politically correct, is if you have a home sprinkler system to water your lawn, or you're a water company managing the water flow to a city, both of you want to remotely control the valve or a set of valves. The potential implications of the home sprinkler system's valve being turned on and off by a potential attack are not nearly as severe as the water company's valve for the whole city being turned on and off. And so, in essence, while you never want to mention that, oh, I won't secure everything in the world, the point is, to secure the home sprinkler system, you're only going to spend a certain amount of money because it doesn't make sense to spend any more money than you'll be liable for should that system fail, okay, or should that system be misused. So if the insurance that you have to take out is $100 a month, you're not going to spend more than $100 a month on securing the system because it doesn't make good financial sense to do so. I'll just take the risk. Whereas if I'm providing the automation for the valve on the water company, now we're talking some more dollars. And it makes more sense to spend more money on securing that environment, different technology, better technology, other technology, more processes and procedures, maybe a little bit more complexity, or not. Maybe a little bit more work to make it less complex. But the point is you'll spend it differently in that environment, which gets back to my point about will there be one IoT environment to rule them all? No. Again, because there'll be different levels of attention to security, if for no other reason. In all of these cases, though, what we stress with IBM, with our IoT security approach, is that you have to pay attention to it at design, you have to pay it at implementation, you have to pay attention to it in deployment, and you have to pay attention to it when you're using these things. Those three areas, you always have to pay some attention. You'll make conscious decisions. You may not necessarily like all the decisions you make, but make those conscious decisions on where you spend and for what reasons in securing your IoT environments. So again, design, deploy, and manage securely. My boss sometimes yells at me for saying, everybody needs to design securely, because he has this point that, well, they never do it anyway, so why are you telling people that? My point is, I have to tell people that is my job. And I like to sleep at night, so we have to design these things securely. And the other point about this, and I think the gentleman just before me made this point, and I want to echo it again. One of the biggest things about designing it securely is making sure you have a way to fix it when it's busted. So get over it, everybody. You're going to have vulnerabilities. Even if you fixed every known vulnerability at the point at which you release something, you'll have a vulnerability within a month, more or less. Why? Because people keep poking at it. It's fun. If it's not fun, it's lucrative. So you're going to have a vulnerability. How do you address such a thing? You have a path to fix it. So one of the most important things to get right is a good path to fix problems when they go wrong. So one of the things I stress the most with designing for security is actually design for change and get comfortable with change. Many organizations, and I saw this in the IT environment as well, many organizations say to themselves, I got it working, I'm never applying a fix again because I don't want it to break. It's like the worst thing you can do overall. Yeah, I get it that you don't want to introduce instability to the system. However, you need to move forward, and continual movement is also a steady state if you think about it long enough. And if you get used to changing things on a regular basis, you'll actually get more comfortable with it, and it won't be such a ceremonial event to make a change to your software. So firmware updates won't be, a gasp and cross your fingers. It'll be, oh, okay, another update. That's where we have to get to with designing securely and being ready for change. Deploy securely. This is all about applying those things that we've learned for years and years and years about what to do and what not to do, and making sure we actually implement those things. A lot of the exploits that we heard about in the last two talks, or 2 or 3 talks, are things that we would have sat back and said, gosh, I could have even done that. And the other side, you say, yeah, and I can see how the developer wouldn't have known to turn that off. It wasn't in the feature list. It wasn't in the minimum viable product specifications, and I was forced to get something out. And I didn't want to take the time to subtract from the environment what I didn't think was necessary for fear that I'd break something else in the process. So a lot of times people will leave stuff in because they're afraid that if they take it out, it'll break. That's a problem, because the more you leave in, the more potential there is for that to be exploited. I can tell you a lot of the vulnerabilities I've seen lately are in toolkits that have code laying around. Nobody actually knows why the code's there. Nobody even knows if the code is actually used. But if it happens to be used, it's a vulnerability. Since people know it's in there, they'll cause it to be used. So this is a tough one, but it's very important in both designing and deploying. Tighten up your interfaces. If you don't need to be listening on a port, don't listen on a port. If you don't need to have an FTP server installed as a part of the Linux OS, take it out. All those types of things, okay? That's design and deploy. And then managing securely, again, this is all about watching what the environment is doing, watching what the systems are doing, detecting anomalies in those systems, watching the behavior of how things are going on, and also making sure that you maintain an up-to-date environment, maintain those systems, and keep those systems running. The last area I want to talk about with respect to IoT security is a little bit more on this risk-based approach to attention to security for IoT applications. I've taken a shot here around a couple of business patterns for IoT applications that I see emerging in the space. Is it the only way to categorize IoT applications? Probably not. Are there other ways you could slice and dice this? Yeah, I think so. But for these purposes, this is a pretty good way to at least start you thinking about what it means to take a risk-based approach. So one way I see IoT being used is sort of within an enterprise. An organization might want to automate their manufacturing facility, and then they want to say, well, not only do I want the instrumentation being known at the manufacturing facility, but I want to know it at the home office so I can optimize things going on around my whole company. It's information, they drop a bunch of sensors around, they instrument everything, they put up a bunch of graphs for the CEO to see on how their manufacturing flows are working. Everybody's happy. The information is all within the enterprise, though. The information is for the use of that enterprise. They're not trying to share it with anybody else yet. They just want to use it that way. That's a particular way of using IoT, and has a particular set of characteristics around it. The type of data that you're collecting, the scope of that information, where you're storing that information, how you're making use of it, and so forth. There's another way. There's another business pattern, if you will, called what I call connecting things with business partners. This is where you might have a couple of companies want to get together and want to share information about what's going on for each other's benefit. Or one organization has been collecting information for a while about how their devices are being used, and they realize that that information is worth something to their friend. In fact, their friend is willing to pay them for it. Now we're doing some information sharing, and then this brings in some different characteristics around, well, what information should I share? How should I share it? What do I need to obfuscate, change, redact, modify, anonymize, and so forth? Different set of security characteristics. Then there's this notion of connecting things with everyone. This is sort of the public service mechanisms. I might have consumer models and customer usage models sort of fall into this space as well. You might not even know the identities within which or that are communicating with you, but you're sort of sharing information in a much wider space. A different set of security characteristics. And then I noticed that these three business patterns really don't cover anything around this notion of safety critical systems. And as we saw earlier, what you might think of as safety critical systems, the ones that first come to my mind, is not the full set of safety critical systems. When I start thinking about the potential to burn down a house by turning on and off the switch on a heater too quickly, that's kind of scary. Okay? And yet, I know of certain devices that would have allowed that. Okay? Not a good thing. Now, is that safety critical or not? That's a fine line. But when we get into these IoT device situations, that's something that we have to consider. And so my last page here is really, when you take a look at confidentiality, integrity, and availability characteristics, and the level of attention you would apply to each of those with respect to those different business patterns that I talked about going down the page here, you'll see that as we move further down and further to the right, your level of attention to security characteristics has to go up. That doesn't mean you don't pay attention to security when you're doing a connecting for the enterprise or connecting in the enterprise. It's just that realize that your level of risk is probably a little bit lower. The information that you're using is a little bit different. And you can pay attention in a different way to the level of security you're applying to these environments. And the last thing I'll leave you with respect to attention to security is really this notion that we, like it or not, we have to factor in the business characteristics or the business elements of this. I mean, I'm an engineer. I want to secure everything. I want to use the best technology that's known. But I also realize that if the device is worth 50 cents, and it's better to just brick the device than to spend more money to try to secure the device, because it's actually cheaper to roll the truck to replace the device than to try to implement the security against the device, then just put in the kill switch. My last point about kill switches is kill switch might not mean shut down everything, as we learned about with the Tesla. Good job to them is that kill switch still lets the thing be driven enough to be safe. So kill switch might mean bring it to a graceful steady state, where steady state might be stopped, or it might be moving in a safe manner. All right, with that, thank you very much. I'm a little bit over, but we started late, so I get a couple minutes back.